So for today's class, we're going to be learning how to solve two-step equations. So last Friday, we went over how to solve one-step equation, and then a fundamental thing to know is that what an equation is. So for example, 2 equals 2 is considered an equation because it has an equal sign in the middle. And what that means is that the left-hand side of the equal sign and the right-hand side of the equal sign are equal to each other. So another way to visualize it is by imagining a scale. So in a scale, you can imagine these blocks to be 1 kilogram each. So on the left-hand side would be 2 kilograms, and on the right-hand side would also be 2 kilograms. So since both sides are weighted equal to each other, the scale is balanced, so it's not tipping over to one side or the other. So if I were to remove this block, then the left-hand side would be 1 kilogram, while the right-hand side would be 2 kilograms. So it's going to be dropping to the right-hand side. So in order for the scale to be balanced again, I have to remove a block from the right-hand side. So that means that whatever you do to the left-hand side, you also have to do to the right-hand side so that the scale could be balanced, and the same thing could be said for equation. So last time we were solving one-step equation such as 3x equals 15. So when we're solving a one-step equation, what we're trying to do is to isolate the variable. So how do we isolate the x in this equation?
You divide by 3.
Yes, you divide by 3. So when you divide by 3 to the left-hand side, what do you have to divide by on the right-hand side?
By 3.
Okay. So you get x equals 5, but we don't know if x really equals 5 unless we plug it into the original equation. So we're gonna do 3 times 5 equals 15, and 3 times 5 is 15 equals 15. And 15 does equal 15, so we know that x does equal 5. Another one-step equation is x minus 3 equals 10. And how do we isolate the x value? What would you do?
Do you add 3?
You add 3. And when you add 3 to the left-hand side, what do you do to the right-hand side?
You also add 3.
Yes, that's correct. So x equals 13. And then to make sure that x really does equal 13, we have to plug 13 back into the original equation. So 13 minus 3 equals 10, and 10 does equal 10. So we know that x does equal 13. So now we're going to move to how to solve two-step equations. And solving two-step equations is the same as solving one-step equation. Your goal is just to isolate the x. So how do you isolate the x?
Would you divide by 2?
No, you don't. The reason why you don't divide by 2 is, do you remember the order of operations?
Like PEMDAS?
Yeah, PEMDAS. Please excuse my dear Aunt Sally. So that'd be parentheses, exponents, multiplication, division, addition, and subtraction. And since we're trying to undo the equation to isolate the x, we have to work using PEMDAS from reverse. So you start with addition and subtraction, and then you do multiplication and division. So for this equation, 2x minus 5 equals 5, what would you do?
Add 5.
Yes, okay. So when you add 5 to the left-hand side, what do you do to the right-hand side?
Add 5.
Yes. So you're left with 2x equals 10. And how do you isolate the x value?
You divide to
Okay.
both sides.
Yes, to both sides. That's good. So you get x equals 5. But like these two equations, you don't know if the x value really does equal 5, so you have to check your answer. So you're going to get 2 times 5 minus 5 equals 5. And then 2 times 5 is 10. So you're going to get 10 minus 5 equals 5. And then 10 minus 5 equals 5. So 5 equals 5, which is true. So x really does equal 5. So I came up with a little jingle to help you guys remember how to solve two-step equations. So when I say isolate, you say the variable isolate.
The variable.
Isolate.
the variable.
When I say check, you say your answers. Check.
Your answers.
Check.
Your answers.
Isolate the variable. Check. Your answers. Isolate the variable. Check. Your answers. So when you're solving two-step equations, what do you have to do?
Isolate the variable and check your answers.
Good job.